Warm greetings, my name is Ji Xuan and today I will be presenting my project for Virtual Innovation Competition MIJC 2026 titled Characterization of Sputter Deposited Molybdenum on PET for Wearable Health Sensors. With the rapid development and advancement of flexible and wearable electronics, there is a growing need for materials that are lightweight, bendable and electrically stable, especially for health monitoring devices. So the problem statement is, most controversial metal films used in sensors are deposited in rigid substrates. When transferred onto flexible substrates such as polymer, its film tends to crack, lose conductivity or fail under bending. This limits the ability to be used in health wearable sensors. Therefore, there is a need to explore alternative materials and deposition conditions that can produce smooth, conductive and flexible thin film that is suitable for wearable health sensors. The objective for my project are to deposit MO thin films on PET substrate using magnetron sputtering, and the second one is to characterize the surface morphology, roughness and electrical properties of the deposited film, and third is to evaluate the suitability of MO/PET thin films for future wearable health sensor applications. As for methodology, the MO thin film were deposited using the Quorum Q300TD sputter coater at different deposition times, which is 3, 6, 9, 12, 15 and 18 minutes. So after deposition, I used these three characterization tools to characterize the thin film, which is SAM, AFM and 4-point probe. So as for the result, for my SAM analysis, there is no grain structure was observed, indicating the MO thin film was very fine and form a smooth, continuous layer on the PET substrate. The surface coverage improvised as the deposition time increased. As for AFM, the surface roughness, or we call as RA, increased from 3.33 nanometer at 3 minutes to 30.362 nanometers at 80 minutes. This shows that the film becomes thicker and the surface becomes more textured as MO accumulates on top of the thin film. As for electrical performance, the resistivity decreased as the deposition time increased. And this is because the thicker film will allow more continuous pathway for electron to flow, reducing its resistance. The novelty of this project demonstrates the potential of depositing MO on PET using a low-cost sputtering system to produce flexible conductive layers. The combination of MO as the metals and PET as the substrate provides a promising route for the next generation low-power wearable health sensors. The benefits of this project can contribute to the development of flexible electronics by providing important insights on how deposition time affects the surface and electrical properties of MO thin films. The improved conductivity and stability of morphology makes MO/PET thin films suitable for wearable health sensor, such as patches, motion sensor, and even diagnostic device. This project has a huge commercialization potential is because these MO/PET thin films can be mass-produced using existing sputtering machines found in many laboratories and industries. The materials are low-cost, processes are scalable, and the thin film can be integrated into a health monitoring device, such as fitness tracker and textiles. This gives a strong potential for commercialization in the growing wearable technology market. This project has not received any awards or publication yet, and this competition marked its first official submission. So as conclusion, the result shows that the longer the deposition time produces MO films with better surface coverage, higher roughness and lower resistivity. Among all samples, the film deposited at 80 minutes, which is the longest, demonstrate that the most stable electrical performance and the lowest resistivity, making it the most suitable for wearable health sensor application. It improves conductivity and continuous film formation, allowing it to perform more reliability under bending and movement, which are essential requirements for flexible sensor devices. So, thank you for watching.